It's Memorial Day weekend, and Mike and I have not been down at the shed for the last couple of weeks because my wife had back surgery, and I've been here at home helping take care of her, and I'm still here, still taking care of her. But I have been doing some stuff during that time, and I would like to show it to you. Mostly, Mike and I wanted to enhance the attract mode capability, so let me show you what we've done. The first thing I wanted to show you guys is a clip of the old attract mode that we had in the pinball machine. I just hard-coded this attract mode. It simply increments the lights, counting up the bonus scores and the lights in the pop bumper, and then it repeats. So I'm going to go in and show you the code that made that work before I show you what I did to completely simplify all of that. Okay, I probably haven't said it earlier, but this video is primarily going to be on the coding of these attract modes. It's mostly going to be Arduino style coding, and so if you're not interested in that, you might as well just skip this one and come back when we film something a little better. I will have a couple of clips of the pinball machine actually running this code though, so there will be a little bit of real pinball in here. But let me start with the old attract mode. Now I'm not going to spend a lot of time on this because I got rid of this. It's not here anymore, but I just wanted to show you what I did originally, quick and dirty. So first I set up a boolean that said whether the attract mode was on or off. I set up an index that points into this array, and I created this array of LEDs that said which LEDs I want to turn on. And one by one I will turn these LEDs on. So I'll turn LED 35 on, LED 34, 33, 32, 30, 41, 42, etc., etc. And those LEDs are the bonus LEDs counting up from the bottom of the table. So the way I accomplish this is in my normal gameplay. Case 2 is where I'm sitting when a game hasn't started yet. So if a game hasn't started, we should be in attract mode. And that brings you down to this else statement right here, where I say if attract mode isn't on already, turn attract mode on and add an event to the timer every 100 milliseconds to do an attract update. Now the attract update routine just comes down here and it says increment the attract index, so point to the next LED. If I'm at the end of the array, set the array back to 0 and negate the state of the attract state. I originally wanted the thing to scan up and back. I'm not actually doing that, but that's okay. This is all gone anyway. And then I check to see if the attract mode flag is still on, and if it is, I add another event to come back here in another 100 milliseconds and update that index again. So the timer simply updates the index every 100 milliseconds. When we go to the update LED routines, there are about 3 different things that I do. First, I check to see if there's been a tilt, and if there has, I turn off all of the LEDs except for the piano LEDs, which I turn to red. So that's done in this section. Otherwise, if attract mode is on, and it is, I go through and I step through the attract mode LED array, and if the current count is less than wherever the index is, I turn the LED on white. Otherwise, I turn it off. And this second section here was was supposed to be the turning them back off again. That part never worked, and I didn't troubleshoot it. So anyway, and the last thing I do in this routine is just the regular light updates for gameplay. So there are a couple of things wrong with this approach to doing the attract mode. While the LEDs are defined in this table of which LEDs will be used in the attract mode, what happens with those LEDs, whether they turn on or off, is dictated by this hard-coded software that says, you know, look at the index and turn it on or off. If you wanted to do something complex, like you know, have 3 lights blinking, you know, in a little circle, while other LEDs are running up and down, and yet other LEDs are staying on constantly, or blinking really slowly or something, it would be extremely difficult to do by coding each of those states of each of those LEDs with hard-coded code like this. The other thing that's a little difficult. The other thing that's bad about this technique is that I have the updates done inside the regular LED output routine, which operates every 50 milliseconds. So 50 milliseconds turns out to be the clock rate at which you can change the attract mode. And if anybody knows anything about clock rates and changing things, you know that you have to, you can't change more than, how should I say this? The rate of change has to be twice the clock rate. So the maximum speed, the fastest that we can change this is every 100 milliseconds. And that is just 10 times a second. And that's not very fast in human eyeball terms. So, so having this embedded inside the update LED routine isn't really very good. And there's no reason for it to be here, since if you're in attract mode, you're not doing anything else but attract. So you might as well spend all your computer cycles updating the lights. So that is the old attract mode, and that's what made those lights step up. So now I want to show you the new attract mode. So here is the new layout. In this procedure, every light in the pinball machine is part of the attract mode. And each light has a 64-bit word that defines what that light will do in one of 64 time intervals. So right now there are exactly 100 LEDs, and that's not a rounding thing. There's actually exactly 100 LEDs on the table right now. So this will grow as we add the back box to it. But right now there's only 100 LEDs. So LED 0, which is the first LED in this matrix, is all ones. And what that says is, in every time step, this LED is going to be on. So that LED is always on. As is LED 1, 2, 3, 4, 5. But you see LED 6 here starts out with zeros, and this is a hexadecimal number, so that's 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1. So for the first 18 time steps, this light will be off. Then it'll turn on, and it'll stay on for however many steps that is, and then it'll turn back off again, as will the one right next to it. And as you step through this array, you can see that all of these LEDs are basically set up to do their thing. Now you might think, wow, this is going to be really hard to set this up so that you know which LEDs should turn on and which LEDs you should turn off. And if you did it by hand, it would be pretty difficult. But I actually built an Excel spreadsheet that let me just X off which lights I wanted on, which lights I wanted off, and then it created the array for me. So I'll give you a quick look at that in a little bit after we get through going through the code of how this works. But this allows me to have an LED that would turn on, off, on, off, on, off if I wanted to. So let me show you a little clip of what this routine looks like when it's running. And this is what's loaded in the machine right now. After I get done with that, I will show you a clip of how it worked originally and an interesting bug I found that that caused that problem. So here you go. Here's what it looks like when this is running. So how did we accomplish this new attract mode? Well, to start off with, I defined an attract speed and I can set it lower than, I can set to any rate I want actually. So right now I have it set to 50. You saw the array that we had defined here for each of the bits. And in the loop, under the same place, game state 2, this actually has not changed at all, except for adding that definable attract speed in here. But if attract mode isn't on, you turn attract mode on and you set an event to activate the attract update. Now, attract update now does all of the display of the attract mode. It no longer goes to the LED output procedures. It does it right here. So it still increments the attract mode index, but now the attract mode index is looking at what time position in that 64-bit word we are currently displaying. So initially we're starting with 0, and then we will step up until we get to 63 and then set it back to 0. So that's what this code does right here. So in order to determine the state of the current bit pointed to by this attract mode index, we need to calculate which bit position we want to test. So we're going to create an attract mode mask. We start out by creating a 64-bit variable equal to 1, and then we take that bit and we shift it to the left 63 places minus the current index. The reason we do that is that we're starting with the high order bit. So bit 63 would be the first bit we want to display, and bit 0 is actually the 63rd or 64th bit we want to display. So by taking the first time through here, attract mode index will be equal to 0. So we will shift the 1 bit 63 bits, which will put it in the uppermost excuse me, uppermost bit location, and that will become the attract mask that we will use in our testing throughout the following loop. So now we look at our matrix in the current position. So we're stepping through all 100 locations here with this for loop, and so we start off with the first one, word 0, and we AND it with the attract mask, and that's a test. So if that equals a 1, then we turn on the LED, otherwise we turn off the LED. And we just step through doing that for all 64 of those, or all 100 of those locations, and then we show the LED strip. Then we check to see if the track mode is still on, and if it is, we set up another event to do this in another 50 milliseconds. And that's it. Simple, clean, easy. This never has to change in order for us to change the whole order of how the things are going to get displayed. It just runs through and works perfectly. So now I want to show you the little problem I had when I first set this up. So here's a video of how it originally started out, and you'll notice that the lights start off like all off. They kind of flip on, and then it kind of scans halfway through and then starts over again. So here, take a look at this. Now, here is the version of the code that caused that error. It's a pretty simple thing, and if you've been programming for a while, you'll probably have run across this already. But for some people who are newer in the software world, this could be pretty daunting, I guess. So here's the way my code originally looked. I created a 64-bit attract mask by taking the number 1 and shifting it however many bits up, the first time it would be 63 bits to the left to create my mask. The problem is that this 1 is not a 64-bit number. It is a 32-bit number. So after 32 shifts, this just becomes a -1, or a minus whatever number. And then it shifts completely off and it becomes zeros. So it's not pointing to anything. So that is what dictated how those lights were being messed up. So the first 32 bit locations were never shown because the math here wasn't working. Now I probably could have just cast this one as a 64-bit number, but I opted to set a variable that was a 64-bit variable just to make it a little bit cleaner and easier to understand for me. Okay, now I want to show you the Excel spreadsheet I created that helps me lay out the light pattern that I want to use. And this particular light pattern is actually one that Mike put together because he wanted something that looked like a windshield wiper sweep across the bottom, where it would sweep across turning the lights on, and then it would follow sweeping across turning the lights off. So this is the matrix that makes that happen. And as you can see over here on the left, we have each of the 100 LEDs defined by name, so we know which LEDs there are that you can turn off and on. And Mike even color coded them a little bit just to make it easier for himself. And all you have to do is put some character. It doesn't have to be an X, but any place where you want the light to be on, you just put a mark in the time slot. So this goes from time slot 1 through 64, or 0 to 63, however you want to count it. And that tells you which one to come on. Now, Excel, strangely enough, doesn't do 64-bit math. It only does 32-bit math, so it was a little difficult to convert. I had to take these X's, convert them into numbers, and then convert them into hexadecimal. So the first thing I did was just convert them all into ones or zeros, and then I took those and I blocked them into groups of 4 because I want to get them into hexadecimal, and then I converted them to hexadecimal numbers, and then I finally concatenated all those hexadecimal numbers together to get my matrix. So all I have to do to use this matrix is come in here and mark where I want the lights to be on or off, and then come over here and just copy this column, paste it into my code, and I'm done. So it's really easy to modify and change. To make it even a little easier for Mike to understand which lights to turn off and on, he did a little layout of the table showing what the LED number for each LED was. So you can see that, like these GI bulbs, he just turns all the GI bulbs on. So all of these numbers, 0, 1, 2, 3, 4, and you remember you saw 0, 1, 2, 3, and 4 was the ones I showed earlier in there that were all turned on. Well, they were all turned on because they are the GIs under this piece of code. So the only lights that he's using in this particular attract mode are the ones that would be active lights on the play field. So that's it. So that's our new attract mode, and we're already talking about, looking at how much memory we have, and maybe loading up 2 or 3 different attract modes and stepping between them and stuff like that. Also, the board that I have built has an EEPROM on it, and we haven't actually populated that or done any code to use it, but if we put that on there, we could have 100 different attract modes set up. So so look for changes to the attract in the future, but for right now, that's it for this video. So thanks a lot for watching. We might get down to the shed tomorrow. I'm not sure. Mike's out of town this weekend, but I think he's coming back tomorrow. And my wife is feeling quite a bit better, and I think she can handle me being gone for a few hours, so we might get down there and play around for a little bit. So anyway, have a great Memorial Day. Thanks for watching. You guys have a great day. Bye-bye.